In this section, we are going to study the shape of molecule. First, let's review the octet rule. In grade 9, you have learned that for the species with 8 outermost shell electrons, what we call octet structure, they are stable. For example, the neon atom or ionic compound. So most of the ionic compound will have 8 outermost shell electrons, or even molecules, for example CO2, they try to have octet structure in order to become stable. But with more knowledge about molecular structure, we find that the octet rule is not always true. Here shows 3 molecules. Both of them don't have 8 outermost shell electrons, but they are stable. So what's wrong with octet rule? In fact, when we study the electron shell, for example, in the first shell, the maximum number of electrons that can accommodate is 18 electrons. That means there is still empty space for the extra electron, or we can say they can extend their electron shell to accommodate more than 8 electrons. Only atoms with period number more than 3 can extend their outermost shell. For the shapes of molecules, what we focus is the number of electron pair. Here shows a chlorine molecule. There are 2 types of electron pair. First is bond pair electrons, and the second is lone pair electrons. In this diagram, there are 7 electron pairs in the chlorine molecule with 6 lone pairs and 1 bond pair. But since electrons carry same charge, they tend to repel each other. The possible solution is the electrons should be separated as far as possible. For the species with 2 electron pairs, like beryllium hydride, BeH2, because they got 2 bond pairs, the maximum of furthest separation is 180 degrees, like this. So the structure, what we call is linear, because they got 2 electron pairs, and the shape is also linear. For those species with 3 electron pair, like BF3, they try to separate into 3 identical angles. It's 120 degrees, like this. So the structure is trigonoplanar, because all 4 atoms can be located in the same plane. That's what we call planar, and the shape is trigonoplanar. So you may think for the 4 electron pair species, like CH4, the 4 bonds will get 90 degrees between them, but this is not true, because what we forget is the molecule actually has 3-dimensional structure. With 3-dimensional, the CH4 molecule should look like this, tetrahedral, with the bond angle 109.5 degrees. Here we have introduced 2 new symbols. The first one is solid triangle, illustrate the bond come out from the plane of paper. And the dotted one means the bond go into the plane of paper. Well, we have plane of paper here. The 2 CH bond, they lie on the plane of paper. But the solid black one, they point out like this. And the dotted one is behind the plane, like this. So the molecule is 3-dimensional structure. The bond angle between CH bond is 109.5 degrees. It's more than 90 degrees that shows in the 2-dimensional one. So we can assume that the 3-dimensional one is better. The shape for 4 electron pairs is tetrahedral, and the shape is also tetrahedral. And you can see the amination for the methane molecule. Next species also contain 4 electron pairs, that is NH3 ammonia. But a bit different is they contain 3 bond pairs and 1 lone pair, like this. Again, this is 3-dimensional structure. But since they got 4 electron pairs, so the structure is also tetrahedral, but the shape is trigonal pyramidal shape. And from the amination, you can see you cannot locate all 4 atoms on the plane. And that's why it is different from trigonoplanar. This time it's trigonal pyramidal shape. Finally is 4 electron pair species with 2 lone pairs and 2 bond pairs. That is water, H2O. And here shows, because all 3 atoms can be located in the same plane. So even though the structure is also tetrahedral, because they got 4 electron pairs, but the shape is V-shaped. And from the amination, you can see all 3 atoms can be located on the same plane. This is a 2-dimensional molecule. For the 5 electron pair species, we have a typical example, PCl5, and here shows the 3 PCl bond in the middle actually is a trigonoplanar structure. But this time, the structure is called trigonal bipyramidal, because we got 5 electron pairs, and the shape is also trigonal bipyramidal. Finally is the species with 6 electron pairs, for example SF6 with 6 bond pairs like this. The structure is octahedral with 90 degrees between every adjacent bond, and the shape is also octahedral, so you can see the structure from the animation. At this point, maybe you can notice that the structure is actually depends on the number of electron pair, but the shape which is depends on the bond pair and lone pair electron. It is because the lone pair electron we cannot see, but they exist and create repulsion with other electron pair. So that's why they are not included in the shape. And this table summarizes for what we have learned so far with electron pair and the number of bond pair and lone pair electron. You got different structure and shape. So you can find that for the 4 electron pair species, all of them got tetrahedral structure, but with different number of lone pair and bond pair, they got different shapes. So again, shape doesn't mean or doesn't equals to structure. And that's the end of this video.